Forget everything you think you know about the periodic table, because apparently elements aren't permanent, which feels like something they probably should have mentioned earlier. That seems pretty important. Turn lead into gold, helium into uranium. That sounds like a fantasy, but it's not. Today, we're answering a completely reasonable question. How do you turn one element into another? All you need is advanced physics, extreme energy, and the confidence of someone who shouldn't be allowed near atoms. This is elemental transmutation, and things are gonna escalate quickly. Before we start committing crimes against chemistry, we need one base rule. An element is defined by how many protons it has. That's it. Not the color, not the vibe, not how expensive it is, just protons. Hydrogen has 1 proton, for example. Carbon has 6, gold has 79, uranium has 92. Those are each their own elements. Change the number of protons and congratulations, you've made a completely different element. So in theory, if you can add or remove protons, you can turn anything into any other thing, which is a sentence that should make you slightly uncomfortable. For hundreds of years, alchemists tried to turn lead into gold. They failed. A lot. Which is kinda awkward because modern scientists figured out they were technically right. Lead has 82 protons and gold has 79. So all you need to do is remove 3 protons. That's easier said than done. Imagine you have a bowl with 82 balls of lead. You can't just take out 3 and all the balls turn into gold. That's just not how science works. You need a particle accelerator. They're pretty affordable, just a couple $1 billion. Next, you need to accelerate the particles to absurd speeds. Then, you launch them directly at the lead atoms and hope something useful happens. If you hit the nucleus just right, you can knock out the 3 protons you need. Do this over and over again, and eventually, you get gold. Yes, gold. Except, not a lot of it. To get just a single atom of gold, you'd need around 1 trillion atoms of lead. And that's being really generous. This is because atoms are really tiny. Most of the time, the particles just shoot past the lead, not hitting it at all. So, after spending billions of dollars and several years of your life, technically you succeeded. Financially though, you just made a bunch of terrible decisions. You would have made more money just buying gold. But sure, you did it the dramatic way. Now, let's do something even crazier. We're going from helium to uranium. This is no longer just expensive science. This is you versus the universe. Helium is tiny and uranium is gigantic. So we need to build up, step by step. This process is called nuclear fusion. Step 1, you smash 2 small nuclei together. Step 2, keep doing that. Step 3, never stop doing that. This is what stars do, so basically become a star. Inside stars, elements slowly get heavier. For example, hydrogen becomes helium, which becomes carbon, which becomes oxygen. The fusion slowly creates heavier elements. But then the universe hits a limit. Iron, fusion just stops giving energy. So now we have a problem. Uranium is way heavier than iron. So how do we get it? We need something more intense, a supernova. Step 1, obtain a massive star. Step 2, wait several billion years. And then step 3, let it explode violently. The explosion creates so much energy that atoms get smashed together in ways that aren't normally possible. That's actually how uranium is formed. Every uranium atom on Earth was created in a star that exploded so hard it briefly outshined entire galaxies. Now, can you recreate this? Hypothetically, yes, but realistically, that's not how it works. Who knew that recreating interstellar processes isn't that easy? Kind of crazy, I know. Surprisingly, this one is pretty normal, which is terrifying in its own way. We're turning uranium into plutonium. Good news, no star required. Better news, no particle accelerator either. Bad news, you need a nuclear reactor. Just casually access one, I guess. Or go to Chernobyl, that works too. Inside a reactor, neutrons are constantly flying around. They're everywhere, and no one's really stopping them. The uranium-238 absorbs a neutron and becomes uranium-239. This new isotope is pretty unstable. An isotope is basically a variation of an element. If you add one extra proton, it becomes a new element. If you add one extra neutron, it becomes a new isotope. The new neutron turns into a proton. This is called beta decay, but it's actually an upgrade. The uranium-239 becomes neptunium-239, and this is still pretty unstable. So it adds another proton. Neptunium-239 becomes plutonium-239. Congratulations, you have created a new element. No billion-dollar machine, no exploding star, just a reactor quietly doing transmutation like it's part of its daily routine. Which, now that I think about it, it kinda is. This is how plutonium is actually made, so don't try this at home unless you want some government agencies very interested in your hobbies. So yeah, that's how you turn one element into another. These are just a few examples. Technically, you could do this with any two elements. All you need is a particle accelerator, a nuclear reactor, and ideally, a dying star. Very beginner-friendly setup. We went from alchemists dreaming about gold to modern scientists actually doing it. I mean, it's not efficient or cheap, but it's successful. If you think altering elements is insane, just wait till you see what we're doing with DNA, because editing matter was just a warm-up.